Since that last video had a lot of derivation in it, it seems like pretty prudent to do a pretty simple example just to show you how the integral formula works. So in this particular, give you a second here if you want to pause and write down the problem. All right, in this particular problem, we've got a varying rate of payments coming in with a rate of 7k plus tk for the unit time. We don't know what k is. That's our goal for solving in this particular problem. We also have a varying rate of interest where the force of interest, the formula for the force of interest at time t is given to you by 1 over 7 plus t. They tell you the accumulated value in the account is 22,344. And again, like I mentioned before, we want to figure out what k is. So using the formula that we had last time, we know that the present value, because remember the formula we had for last time was present value. The present value is the integral over the time period, so in this case 0 to 12, of our payment stream. So that's the 7k plus tk, e to the integral of the negative, e to the negative of the integral from 0 to t, from 0 to whatever the time is at that particular instant, of the force of interest, ds. All right, it's not too hard to integrate that particular formula. 1 over 7 plus s is just natural log of 7 plus s. We evaluated that from 0 to t. We've got that negative in there, so when we evaluate that, we get natural log of 7 over 7 plus t, and since we're in the exponential here, those cancel out nicely to give you 1 over 7 plus t in, sorry, I was pointing in the wrong spot, in the integral formula over here. Also notice that since the k is a constant here, I factored it out in front just to keep it going along for the ride. All right, now notice that the 7 plus t's cancel, so that makes the problem a lot easier. And this is pretty indicative of this type of problem. If you see it on exam FM, the integrals tend to be fairly straightforward. Either this is going to cancel out and you're going to get something nice here to integrate, or you'll get a nice u substitution problem to do. So even though the formula looks ugly, usually after you get this e to the power integrated piece, you're going to get something that's nice to integrate without too much difficulty. In this case, we just need to integrate 7, which of course from the interval from 0 to 12 gives us 84k. That was the present value. We're given accumulated value. So using a chapter 5 idea, we know that the accumulated value is going to be the present value and then moved forward by the force of interest formula. So our present value in this case is the 84k. Our force of interest formula is e to the integral over the force of interest formula. So again, we get natural log of 7 plus t. We can check pretty quickly that that gives us 19/7 for that particular value. And now if we solve for k, we'll get k as 98.